Hello, hello, my dear friends. Anyone is in live? Hello, my dear friends. Anyone is in live? Hello, my dear friends. Anyone is in live? Hi, Richard. Hi, hi, hi. How are you? Hi, Jasmine. Hi, how are you all? Richard, may. Hi, Praneeth. Hi, hi. I am fine. I'm fine. Hi, Charan. Hi, hi. Richard, may I know? I am good. I'm good. And you? Richard, may I know where are you from? And which standard you are, and for the which stream you are preparing, either JEE mains or NEET or anything. Hi. Right. Okay, fine. Good. Now, okay, okay, my dear friend. Okay, fine. Right. Now, my dear friends, today we are going to start the one very interesting and very application part of our organic chemistry, and the chapter that is called as the amines or nitrogen containing compounds. Right, my dear friends, I will start the lecture. In the middle, if you are having any doubt, you can text in the chat box whether you are understanding or not. My dear friend Richard, I think so. This chapter, which I was going to teach, is of not of your 11th standard. It is of the 12th standard. Now, right now, when I was asking the question, right? If you know the answer, try to answer. If you don't know, give me the question mark. Right? Okay. Any one of the 12th and the dropper? Anyone? Anyone is in the live of 12th and as well as the dropper? The one who is in the live, anyone from the 12th or droppers, either maybe the NEET or JEE. Okay, fine. Then you can listen, no problem. Then you can listen. Right. Now I'm going to start the lecture. Okay. May I know this craft? Okay, fine, man. This is for your mains as well as need for your MSET or craft. May I know your name? And before the going to start the class, first you say me whether the video and the audio is clear. If the video and the audio is clear, then I will start the lecture. Video and audio is clear for everyone. Everyone, the video and the audio, if it is clear, I will start the lecture. Yes, clear, right. Right. Done. Now, okay, fine. Now, now the very interesting chapter and very small chapter and the interesting chapter, that is the amines. Clear? The chapter we call it as a amines. Now, before going to before going to start the amines, we want to clarify IUPAC and the classification of the amines. Right? First, we are going to see the classification of classification of amines. Now, in the classification of the amines, many of the students, thank you, my dear friend, thank you. Clear? This type of the compliments are more enough for me. Clear? Now, classification of the amines, many of the students, they will get confused and they will get what? Confusion over the 1 degree amine, 2 degree amine and the 3 degree amine. Now, the first we are going to see that is a primary amine. First we are going to see that is primary amine. Now what is the meaning of the primary amine? That is CH3 NH2. If the N is attached to the one carbon, then that we call it as a primary amine. If suppose here for the benzene, if it is attached in this manner also, this one we call it as a primary amine only. So also we call it as a primary amine only. If the nitrogen, if it is attached to the one carbon, then we can say it as a primary amine. My dear friends, you have to be very careful with this one. Many of the students, they will get confusion to identify the which is a secondary amine, which is a primary amine and which is a 3 degree amine. Right? Now 2 degree amine, if you want to find, now 2 degree amine, now the nitrogen should be attached with the 2 carbons. If the nitrogen, if it is attached to the 2 carbons, we can say it as a secondary amine. Clear? Namaste Abhinay, good evening, good evening. Now next one, 3 degree amine. Now what is the 3 degree amine? If the nitrogen, if it is attached with the 3 carbons, then we can say it as a 3 degree amine. Clear? My dear friends, you have to be very careful. Right? Now the nitrogen, this NH2 can be act as a functional group also. But many of the students, they will get confused between the alcoholic and the 1 degree amine and 1 degree alcohol. Here you can see this R NH2, we can say it as a 1 degree amine. Now R NH R, we call it as a 2 degree amine. Next R N R and R, we call it as a 3 degree amine. But when it comes to the alcohol, now this is a 1 degree alcohol. Now we can say this as a carbon, if it is attached to the 2 other carbons, we can say it as a 2 degree alcohol. If the carbon attached with the 3 other carbons and that carbon, if this OH it is attached, then we can say it as a which one? We can say it as a 3 degree alcohol. But you can see nitrogen should attach to the 3 carbons, then only we can say it as a 3 degree amine. Right? Here it has attached to the 1 carbon, right? So it is 1 degree amine. So many of the students, they will get confusion in the 1 degree alcohol and 1 degree amine. And the 2 degree alcohol, 2 degree. See, here this carbon is attached with the 2 other carbons and the secondary carbon, the OH is attached to 2 degree alcohol here. But when it comes to the nitrogen, you have to consider nitrogen itself directly attached to the alkali groups or carbon. Then only we can say it as a 2 degree amine. Now this is a 2 degree amine. Right? Now this is a 3 degree amine. I hope it is clear for you all. The difference between the alcohol and the amines classification. Many of the students, they will get confusion here itself. 1 degree amine and the 1 degree alcohol, 2 degree amine, 2 degree alcohol, 3 degree amine, 3 degree alcohol. I hope it is clear for everyone. I hope it is clear for everyone. I hope it is clear for everyone. Right, done. Now, clear? Now we'll see the some IUPAC of these compounds which we are going to see. Some IUPAC of these compounds. Some IUPAC compounds of amines which we are going to use in our chapter. That IUPAC of that compounds we are going to see. First one is a first compound repeatedly we are going to use in this chapter, and this compound name is the aniline. This compound name we call it as a aniline. Clear? Next one. The next one we are going to use in the middle. Clear? Now the compound name we call it as a 2-amino toluidine. This one we call it as a 2-amino toluene. 2-amino toluene or ortho toluidine. Ortho toluidine. Clear? Right? Next one. The next one we are having NH, CH, CH3. This one we call it as a N-isopropyl benzenamine. Benzenamine. N-isopropyl benzenamine. Right? Next one. Now I will write the one molecule. Now you have to say me its IUPAC name. Can anyone say me the IUPAC name of this compound? Can anyone say me the IUPAC name of this compound? Yes, good. NN dimethyl benzene. NN dimethyl aniline or NN dimethyl benzene, or we can say NN dimethyl aniline also we can say. Right? The name of this compound? Name of this compound? And the another compound? Name of this compound? One compound name, two compound name, and three compound name. One compound name, two compound name, and the three compound name. One is pyrrole, good. Second is pyridine, okay, good. Then third. What is the name of the third? Third one. If you know, you can say. If not, give me the question mark. No. It is not cyclo. My dear friend, it is not cyclo. There is a one common name for it. Right. Okay. I will explain. Now, this compound name we call it as a pyridine. Clear? Now, this one we call it as a pyridine. Okay? Now, this one we call it as a pyridine. You have to remember this one in the statement based question they may ask. We are having the chance to ask the questions. Right? Now, first, now we are going to see the preparations of the amines. Okay? Now, we are going to see the preparation of amines. Now, in the preparation of the amines, the first we are going to see reduction of nitro compounds. Now we know, right? Reduction means addition of hydrogen or addition of electrons. Addition of hydrogen or the addition of electrons. Clear? And the removal of oxygen we call it as a reduction. First one, this nitro compound in the presence of tin and the acidic medium and the base and metal plus acid. Next, Fe plus HCl plus Zn plus HCl right? Now here the Zn plus HCl and LaH. This all the reagents, what it will do? It will directly, it will convert the nitro compound into anil or NH2. Nitro compound into, good evening Dinesh, good evening. Here nitro compound into NH2. Now we'll see how the mechanism it is following. First one, if you take any nitro compound, like nitrobenzene or anything. Now this is a one nitro compound. Now this nitro compound, which one dilute HCl? What, my dear Abhinay, what is your doubt? What dilute HCl? I mean, you are asking whether the given one is a dilute HCl or strong HCl. I mean, that you are asking or any other? What is your doubt, Abhinay? Now, listen. Here, in the presence of, it is a dilute, it is HCl only, dilute HCl only. Okay? The HCl they will mention. Okay, fine. Right? Next. Here, what we are having? This metal will readily lose the electrons, right? Metals will readily lose the electron, right? In the HCl, hydrogen will lose the what? Hydrogen will be lost its lone pair of electron, its bond pair of electron. From this metal, the which has the electrons it has lost, that hydrogen it will be gained and it will become the nascent hydrogen. Clear? Now this nascent hydrogen is the responsible for the reduction. From the metal, the whichever the electrons it has lost, that it has been gained by the whatever the HCl. In the HCl, this more electronegative element, it will take the bond pair of electron and it will become the H plus. Whatever the electrons has lost by the metals will readily lose the electrons, right? So this nascent hydrogen, what it will do? It will reduce all the oxygens and the hydrogens will be added. But my dear friend, to convert into, from this nitrobenzene to convert into aniline, this nitrobenzene to convert into aniline, how many moles of nascent hydrogen is used? Can anyone say me? How many moles of nascent hydrogen is used? How many moles of nascent hydrogen is used? Can anyone? How many moles of nascent hydrogen is used? No. Now you see. No, not 4. No. Now listen. Here, first, here the metal will, no, not 3. Listen. No. Now, first, the metal will readily lose the 2 electrons. Now, the HCl, we are having the plenty of hydrogens. Now, the 2 electrons will be taken by the 2 hydrogens. Now, first, here the 2 moles of the nascent hydrogen is used. Here the 2 moles of nascent hydrogen is used. When the 2 moles of nascent hydrogen, when it has used, then it will become, right, here the NH and it is a double bond O. Clear? Again the metal will readily lose the 2 electrons. Again we are having the 2 moles of the nascent hydrogen. Now again it will be, here the one bond will be broken. Now here the hydrogen and here it is a hydrogen. Now what it will become? Now here it will become the NH and here it is a OH. Right? NH and the OH. And here it is a H. Right? Now, next again, here it will be When it has become the H, again here the bond will be broken. Again here the bond will be broken. Now it will be converted into the NH. Again here the 2 moles of electrons and here it is a 2H. Again it will be converted into NH2. Total how many moles? Total 6 moles of the hydrogens it has been used. 6 moles of the hydrogens it has been used. Right? Is it clear? No, 6, total 6. Total the 6 moles of the hydrogens it has been used. Okay? Now, next. Total 6 ticks. Here the 2, here the 2 and here the 2. Total the 6 moles of the hydrogens it has been used. Now the second preparation method. Yes. Now the second preparation method we are having, that is aminolysis of what happened? Here it will be, sorry, here the H will not add. Here. Right. Here. Right. Okay. No. Here the H will not add. Now, here the H will not add. Sorry. Here when it has drawn the break in, it will, right. My dear friend, up to 11 I will, max 11 I will stop. Right? Now, next the aminolysis of the alkyl halides. Aminolysis of the alkyl halide. Now, in this aminolysis of the alkyl halide, first one here NH3 in the presence of alkyl halide. Now, it will be converted into the ammonium ion. It will be converted into the ammonium ion. When it has converted into the ammonium ion, now which mechanism it has followed here? Can anyone? Which mechanism it has followed here? Which mechanism it has followed here? Which mechanism it has followed here? Can anyone say me which mechanism it has followed? No. How come half mine? Okay, Richard. Bye. Now, here this lone pair of electron of this ammonia will be attacked from the back end, and this halogen is a good living group. It will be take the bond pair of electron and it will be eliminated. And here the mechanism it has followed, that is a SN2. That it has followed the SN2 and it will form the ammonium ion. Then after the ammonium ion, when it has formed, now this X minus will readily abstract this acidic hydrogen. This readily abstract this acidic hydrogen, and the sigma bond pair of electron will be taken by the which one? Nitrogen. Then again it will become the primary amine, and it will become the primary amine. Then after that again this primary amine, again it will react with the alkali halide in the form of the SN2 reaction. Again this bond pair of electron will be eliminated. Again it will convert into the which one? NH2, and it is R. Right? Again this halogen which has eliminated, now it will take this acidic hydrogen. It will take this acidic hydrogen, and again it will become R, lone pair of electron, here the H, and here it is a R. Again it will be reacted with the alkali halide in the form of the SN2. Right? Again it will become the 3-degree alcohol. It will become the 3-degree alkali halide in this manner. Right? Again this negative charge of this negative charge of this halogen, negative charge of this halogen, what it will do? It will readily abstract this one and it will take the bond pair of electron and it will become the 3-degree amine. Right? After becoming the 3-degree amine, now I will continue from here. After becoming the 3-degree amine, again the 3-degree amine, it is having the lone pair of electron, right? Again it is having the lone pair of electron. Again this lone pair of electron will abstract. It will in the form of the SN2 reaction and it will take this bond pair of electron and it will become the quaternary salt. Now it will become the quaternary salt. My dear friends, you have to be very careful that nitrogen maximum to maximum covalency. Nitrogen covalency is 4. Nitrogen covalency is 4. Means nitrogen maximum to maximum it can form the 4 bonds. This you have to be very careful with this one. How many bonds the nitrogen will form? Nitrogen will form the maximum to the maximum, the covalency of the nitrogen is 4. Right? Now, here the number of Rx, what they will ask you, the questions they are asking from the aminolysis is the number of moles of Rx compounds reacted for the preparation of quaternary salts. Now you see my dear friend, to prepare this quaternary salts, how many moles of the Rx has been used in this reaction? Now say me, how many moles of the Rx has been used in this reaction? 4 moles, right? Now to identify that one, so I will give you one trick. The number of moles of Rx compounds. Good evening, Elia. Good evening. Rx compounds reacted for preparation of quaternary ammonium salt. Now that will be equal to the number of H attached, that is equal to the number of hydrogens attached to the nitrogen plus number of lone pairs on nitrogen. Clear? This if you see directly you can predict the how many Rx has been reacted to form the quaternary salt. Let's suppose now if they have given this one. Now how many moles of Rx will be reacted to form the quaternary salt? How many moles of Rx will form? Rx reacted to form quaternary ammonium salt. Now say me. I am fine, Elia. I am fine. And how are you? That is 3, right? See, here the hydrogens are 2 and 1 lone pair. So the Rx reacted here it is only 3. Rx reacted here only it is 3. Right. Good. Next one. And the next one we are going to see, that is reduction of nitrile. From the reduction of nitriles, now we are going to see. What is the reduction of nitriles? Now RCN in the presence of H2 and the nickel, ORR lithium aluminum hydride, ORR sodium amalgam. Clear? Sodium amalgam in the presence of ethyl alcohol. Right? This all what it will do? It will readily convert the nitrile into the primary amine. It will be converted into primary amine. Let's suppose if they have given the benzonitrile upon H2 and the PT, if they have given, it will readily convert into the which one? It will be converted into the benzyl amine. Clear? It will be converted into the benzyl amine. Right? You need the mechanism or you will remember? My dear friends, will you remember? Or should I say the mechanism? Should I say the mechanism or should I go? Okay, right. Done. Any other? If you need the mechanism, just adding the H plus. That's it. Just adding the H minus, lithium aluminum hydride, right? Hydride. This all will give you the hydrates, right? So it will just adding the H. Right. Okay, fine. Okay, fine. Now we'll move. Now next one. This is the very important, my dear friends. You have to remember. That is, if suppose benzonitrile they have given. Benzonitrile upon tin in the presence of HCl and SnCl to HCl. So you have to be very careful with this one. Okay? Right? Now here tin in the presence of HCl if they have given, SnCl2 in the presence of HCl they have given. May I know what is the compound we will get here and what is the compound we will get here? What is the compound A and what is the compound B here? Can anyone? What is the compound A and what is the compound B? A is benzylamide. Okay, good. Then B, acid. Aceta. I exactly, it is not appearing for me. No, my dear friend, I know you will get confused here. B is not the same. B is the Stephen reduction. My dear friends, I know only the metal in the presence of HCl, it will give the benzylamide. It will give the benzylamide. Okay. Then this tin in the presence of HCl only, it will give the benzylamide. But in the SnCl2 in the presence of HCl, this is a Stephen reduction. This is Stephen's reduction. Stephen's reduction, now this cyanide will be converted into aldehyde. So you have to be very careful, and in the statement based question they may ask. So you have to be very careful with this one. See the reagent carefully and try to predict the product. Don't be in a hurry. Metal in the presence of HCl, it will give the benzylamide. Right? Now, this one, cyanide in the presence of SnCl to HCl, this is Stephen reduction. It will not give you the benzylamine, it will stop the reaction at aldehyde stage. Clear? Right? Done. Now, next. What chain? Now, next, fourth one, reduction of amides. Reduction of amides. Yes, benzonitrile. What? Now the reduction of amides. First one. Now this is a acid amide. Now acid amide in the presence of lithium aluminum hydride and the H2O. Suppose if they are given, directly it will be converted into the primary amide. Clear? Now the acid amide. Clear? Which one I have to explain? My dear Hariprasad? Which one I have to explain? Can you say me which one I should explain? This one, this benzonitrile. This metal in the presence of HCl, if they have given, it will readily convert into the HCl. It will readily convert into the benzylamine. Then SnCl to HCl if they are given, this is a Stephen reduction. Already I was explained very clearly with the mechanism in the which one? In the carbonyl compounds. In the carbonyl compounds I was explained very clearly. In this carbonyl compound, this mechanism and everything I explained very clearly. Once you go and see over there you will get very clearly. SnCl2 plus HCl they have given, that is Stephen reduction. This cyanide will be converted into the aldehyde. If only Sn plus HCl they have given, it will be converted into the benzylamine. Right? Okay. Now, these are the some preparations of the amine. Now, the very important reaction that we are going to study, that is, it is a preparation methods of the primary amine. Now, this is a preparation methods of the primary amine, that is Gabriel thalamide synthesis. From the Gabriel thalamide synthesis, how to prepare the primary amine, now we are going to see. How to prepare the primary amine. Now, my dear friends, in the Gabriel thalamide synthesis, it will follow the SN2 mechanism. Only the aliphatic amines can be prepared, but there is no any chance of preparing the aromatic amines. Here, in the aromatic amines will not give you the nucleophilic substitution reaction, right? Here we know, right, only the aliphatic amine, that to the primary amines, primary alkali halides only will give you the, which one? SN2 reaction. But which one? Halobenzene or alkali or halogens which are attached to the aromatic ring, it will not give you the SN2 mechanism, we know, right? In this Gabriel thalamide synthesis, it will follow the SN2 reaction. That it is following the SN2 reaction means the alkali halide which we have taken, that it should be in the primary only. Right? Now we'll see the mechanism. First, this alkali halide in the presence of thalamide, right? In the presence of the base, again the thalamide will be restored, thalic acid will be restored and we'll get the, which one? Primary amine. And we'll get the primary amine. Now we'll see how it is getting the primary amine. Now we'll see the mechanism. First one, when we have taken the thalic acid, now this is a thalic acid. Now, thalic acid, ammonia and the heating when we have did. Now, as the H2O, it will be eliminated and it will be converted into the amide and it will be converted into the acid amide in this manner. Right? Here, when it has converted into the acid amide, here upon strong heating, here you can see this is a one hydrogen. Here one hydrogen. Now as the ammonia, it will take this bond pair of electron and it will be eliminated. Then we'll get the, which one? Thalamide. In this manner we'll get the thalamide. As the ammonia, when it has eliminated, we got which one? Thalamide. After getting the thalamide, now the nitrogen, it is having the lone pair of electron and we are having the one alkali halide, 1 degree alkali halide. This 1 degree alkali halide, this nitrogen lone pair of electron will go and attack from the back end and the halogen good leaving group, it will be eliminated. Clear? Then when it has attacked the alkali, nitrogen will get the which charge? Positive charge. Nitrogen will get the positive charge. Clear? After getting the nitrogen positive charge, more electronegative atom bearing the positive charge is unstable, we know. Now it will take this sigma bond pair of electron. Again the nitrogen lone pair of electrons will be restored. Right? After restoring the nitrogen lone pair of electron, upon hydrolysis, we know, upon hydrolysis if you do, more electronegative atom will take the hydrogen and the less electronegative atom will take the which one? More electronegative atom will take the hydrogen and the less electronegative atom will take the OH. Less electronegative atom will take the OH, more electronegative atom will take the hydrogen. Then it will be converted into R, NH2, and it will be converted into the, again the phthalic acid will be restored. In this manner the phthalic acid will be restored. When the phthalic acid it has been restored, we are having the which one? Here we are having the base. Here we are having the 2 moles of the base. Now the 2 moles of the base will readily abstract this protons and it will be converted into the this O minus and the K plus and it will be restored. Right? I hope it is clear. I hope it is clear. Or still you are having any confusion? I hope it is clear. Mechanism it is clear. Mechanism and everything it is clear. Or still you are having any confusion? Or still you are having any confusion or is it clear? Aromatic primary amines cannot be created from the Gabriel phthalimide synthesis. My dear friends, you have to be very careful. From where I have to explain? Abhinay, I mean like from where? Mechanism once again I have to explain. Mechanism once again to see, nothing is there. Here to prepare the, here you can see in the Gabriel phthalimide synthesis. Now this is a phthalimide. This is a phthalimide. Phthalimide in the presence of the base, and when you reacted with the 1 degree alkali halide, now our main criteria is to prepare the amines. Clear? Now to prepare the amines. Again to prepare the amines, again the phthalic acid is restored. So how it has prepared, now we are going to see. You see, first when we have taken the phthalic acid, sorry, this is phthalic acid. Phthalic acid when we are heated with the, which one? Ammonia in the presence of heating. Ammonia in the presence of heating when we have did, what it has happened? Now ammonia we know, right? This ammonia, it is having the H. Now as the H2O it will be eliminated. As the H2O it will be eliminated. As the H2O when it is eliminated, we will get the amide here. After getting the amide, upon the strong heating, this NH2 and this H as the bond pair of electron it will be eliminated. As the ammonia gas it will be eliminated. As the ammonia gas it will be. After the ammonia gas it has eliminated, this nitrogen and this carbon will form the bond, and what we got with this we call it as a phthalic acid. Clear? Sorry, this is a phthalimide. Now after getting the phthalimide, this nitrogen lone pair of electron will go and attack alkali halide SN2 reaction it will do. From the back end it will be attacked, and this halogen being the good leaving group it will be eliminated from the back side. Right? After it is eliminating from the back side, now you can see here. Now here we got the aromatic ring, here the double bond O. Now here the nitrogen it will get the positive charge. Now here it is having the hydrogen. Now here it is having the R. Now here it is having the double bond O. Clear? Then this nitrogen lone pair of electrons, again to restore the sigma bond pair of electron will be given. After giving the sigma bond pair of electron, nitrogen again its lone pair of electrons will be restored. Then when we do the hydrolysis, hydrolysis how it will be there? H plus and OH minus, right? H plus and the OH minus. Now this H plus and the OH minus, if you break this bond, because carbon and the nitrogen being the more electronegative, it will take the bond pair of electron. If it is taken the bond pair of electron towards itself, nitrogen will get which charge? Negative charge, right? Nitrogen, if it is getting the negative charge, means hydrogen it will go and attack, right? Okay, I will explain from here in the fresh page. See, after the nitrogen, it is having the lone pair of electrons, and here it is a R, and here it is a double bond O. Clear? Then after the hydrolysis, if you do the hydrolysis, here it will getting the H plus, and we are having the OH minus. Now you see this carbon and nitrogen being the more electronegative, it will take the bond pair of electron. When it has taken the bond pair of electron, double bond O, and here it is a plus, here the OH minus will go and attack. Now here is the double bond O, and here is the nitrogen, we are having the negative charge. That negative charge on the nitrogen will go and attack this positive, so that we got the here the H, and here it is a R, right? Clear? This is R. Then again after this nitrogen being the more electronegative, it will take the bond pair of electron. Then when it has taken the bond pair of electron, again it will get the negative charge. Again when we get the negative charge, in the hydrolysis we are having the H plus, readily it will be abstract and it will converted into the NH2, right? Again here this carbon will get the which charge? This carbon will get the positive charge. Again here we are in the hydrolysis, we are having the OH, right? This OH it will go and attack. Clear? Then again we got the primary amine, and whatever the phthalic acid we have taken in the starting, it will be restored. I hope it is clear. I hope it is clear, or still you are having any confusion. My dear friends, I hope it is clear, or still you are having any confusion. Right. No. Okay. Right. Now the next one, the next reaction we are having, reduction of nitrile, we have seen, right? Now in this reduction of nitrile, sixth one we are having reduction of isocyanate. With the isocyanate, if you take any isocyanate, if you take the isocyanate, from this isocyanate we can prepare the 2-degree amine. 2-degree amines we can prepare by two methods. One is reduction of isocyanate, or by the carbylamine reaction, or by the carbylamine test or the carbylamine reaction. With the carbylamine test or carbylamine reaction, we can prepare the isocyanate. Now how to prepare the isocyanate? First one we are having the CH3. I had, my dear friend, Captain America, I had my dinner and I sat. Clear? Now, if you take the isocyanate, isocyanate in the presence of H2 or nickel or palladium or lithium aluminum hydride or ether, if you take lithium aluminum hydride and the ether, if you take directly, this one it will be converted into the 2-degree amine. It will be converted into the 2-degree amine. Clear? Now the benzene isocyanate, if you take the isocyanate, clear? Now in the presence of the following reagent, it will be converted into the which one? 2-degree amines. It will be converted into the secondary amine, right? 1-degree amine and the 2-degree amines can be distinguished by the carbylamine reaction, right? Carbylamine reaction. Now we'll see the reaction of the carbylamine test. How to distinguish the 1-degree amine and the 2-degree amine. The 1-degree amine and the 2-degree amine can be distinguished by the which one? Carbylamine reaction. Carbylamine test. In this carbylamine test, first one we are going to take the 1 degree amine. 1 degree amine in the presence of chloroform, KOH and heating. Chloroform, KOH and the heating. What directly it will give you the 1 isocyanate. What it will give? It will give you the isocyanate and the 3 moles of the KCl it will give. Now this isocyanate smell, can anyone say me what is the smell of this isocyanate? What is the smell of this isocyanate? Can anyone? Can anyone say me what is the smell of this isocyanate? Ah, it is having the foil smell. Right. Clear? It is having the foil smell. F4. It is foil smell. Now, here how it is giving the isocyanate. Now 1 degree amine. Now, when we are reacted with the 1 degree amine, yes, foil smell. Now this 1 degree amine when we have taken in the presence of chloroform, now that base will readily abstract this acidic hydrogen. Now this bond pair of electron will be shifted towards the carbon, right? Now carbon, it is having the negative charge. Now chlorine, being the good leaving group, it will take the bond pair of electron. When that chlorine, when it has taken that bond pair of electron, now the chlorine we are having the vacant orbital. We are having the vacant orbital and we are having this negative charge, and this negative charge will be delocalized, and this negative charge will be delocalized into this vacant orbital and it will converted into the dichlorocarbon. Clear? Now this dichlorocarbon is a neutral electrophile, right? Now this dichlorocarbon, when it has formed, this dichlorocarbon, it is having the one vacant orbital. Now this lone pair of electrons on this nitrogen will be given, it will be accepted by the dichlorocarbon to this vacant orbital. And when it's a nitrogen, when it has given its lone pair of electron, nitrogen will get the positive charge, right? Clear? Now here it is having the 1 Cl and here it is having the 1 Cl. Clear? And it is having the negative charge on the carbon. Done. Now to stabilize this nitrogen positive charge, it will take this bond pair of electron. It will take this bond pair of electron and the nitrogen lone pair of electrons will be restored. When the nitrogen lone pair of electrons has been restored, now here the Cl and here the Cl and the carbon is having the negative charge. Again this nitrogen lone pair of electron will be delocalized, chlorine being the good leaving group, it will be eliminated. Then again what is the charge on the nitrogen will get? Charge on the nitrogen will get the positive charge, right? Now the carbon the negative charge and it is a Cl. Again to stabilize this nitrogen, this bond pair of electron will be given, right? Now if this bond pair of electron it has given, again the nitrogen will get the lone pair of electron and here it is having the carbon negative and it is a Cl. Again this carbon negative charge, it will be delocalized and the Cl being the good leaving group, it will be eliminated and it will be the eliminated and will get the isocyanate in this manner. Clear? But if you take the 2 degree amines, you will not get the isocyanate. You will not get the isocyanate. Why? Why you will not get the isocyanate? Now the reaction will be stopped at this stage only. Reaction will stop at this stage only. Clear? If you take the, which one? 2 degree amine. 2 degree amine if you take, it will stop the reaction here itself. Because again this nitrogen lone pair of electron, if it is delocalized, there is no any proton to stabilize this nitrogen positive charge. That's the reason if you take the 2 degree amine, it will be stop the reaction at this stage only. So you have to be very careful. Clear? You have to be very careful here. Only the 1 degree amines will be given by the carbylamine test. Carbylamine test will be given by the 1 degree amine only. I hope it is clear, or still you are having any doubts? Still you are having any? Still you are having any confusion? Still you are having any confusion? Clear. Now, my dear friends, now what I will do? Now I will write the amines. Now, which of the amines will give you the carbylamine reaction? Now you have to say it. Right? How many of the amines will give the carbylamine reaction? You have to say it. Now say me, how many of the following will give you the carbylamine reaction? How many of the following will give the carbylamine reaction? Now say me, how many of the following will give you the carbylamine reaction? Now give the numbering. 'Now I was written the 8 compounds, right? One, two, five, eight. One, two, one, two, five, eight. One, okay. Two, okay. Three will not give. Four will not give. Five will give. Six will not give. Seven will not give. Eight will give. Right. Okay. Now, next one. Next one, I will write you some compounds. Now you have to say me whether it will give the carbylamine reaction or not. Now, will this compound will give? Will this compound will give? Will this compound will give you the carbylamine reaction? Will this compound will give you the carbylamine reaction? Will this compound will give you the carbylamine reaction? May I know what is that compound name? May I know what is that compound name? May I know what is that compound name and why it will not give? Ah, this is a urea. This is urea. Urea will not give you the carbyl-amine reaction. My dear friends, you have to be very careful. Now, carbyl-amine reaction will not be given by the urea. Lone pairs are in the resonance. Yes, good, good, good. Now, the lone pairs are in the resonance and it will not be given to the deficiency carbon. Here, the urea will not give carbyl-amine test. Urea will not give the carbyl-amine test, right? Next, again, I will write you some of the compounds. Now you have to say me the answer. Some of the compounds I will write now. This is one. Now this is a two. Now this is a three. Now this is a four. This is a five. This is a six. This is a seven. This is a eight. And this is a nine. Now, how many of the following will give you the carbyl-amine reaction? How many of the following will give the carbyl-amine reaction? How many of the following will give the carbyl-amine reaction and what are there? How many of the following will be given to the two, three, four, six, seven, eight. 2, 3, 4, 6, 7, 8. Still any other? Still any other? How many you got? How many you got? One, one it will give, two it will give, 4, 5, 6, 7, 8. Total 1, 2, 3, 4, 5, 6, 7. 5 also it will give. 5 also it will give. 2, 4, 2, 3, 4, 5, 6, 7, 8. What is the role of the nitro? No, there is no. Primary amines will give you the carbyl-amine reaction. Okay? There is no any role of the nitro. Carbyl-amine reaction will give given by the which one? Primary amine. Is it clear? H. Okay, done. Now, the next very most important the reaction that we are going to see, that is half-mine bromide degradation reaction. The very important reaction that we are going to see, that is a half-mine bromide. There is no any minus I effect over there. There is minus M. Nitro group will show the minus M, but there is no any minus M and the plus M effect over there, right? Just 1 degree amine will readily reacted with the lone pair of electrons. Clear? Because it will become the isocyanide, right? This isocyanide will be stabilized by the which one? Minus M group. Just you see the 1 degree amine or aliphatic amine or primary amine. Clear? That it will give you the carbon-amine reaction. There is no any effect of the minus M and the minus I. Next one, half-mine bromide degradation reaction. Half-mine bromide degradation reaction. The next one we are going to see, that is half-mine bromide degradation reaction. Half-mine bromide degradation reaction. My dear friend, here it is a very important half-mine bromide degradation reaction. Just by seeing the reagent and reactant blindly, you can readily predict the product. But in the many of the statement based questions, they are asking the mechanism. What one descent of the one, this carbonyl carbon will be eliminated. This carbonyl carbon will be eliminated and we'll get the primary amine. After getting the primary amine, but they are asking the mechanism is also somewhat important for the prediction of the compound. Right now, the prediction of the compound in the half-mine bromide degradation reaction, here which is important? Mechanism is also important, but in the mechanism, may I know what is the reagent or rearrangement reaction it has been involved in this mechanism? What is the rearrangement? What is the rearrangement reagent? That is a Wolf reagent. Wolf rearrangement has been involved in this mechanism. Now we'll see the mechanism. Right. First one, we are having the 1 degree amide. Now we are having the 1 degree amide. This 1 degree amide in the presence of the strong base, base will readily abstract this acidic hydrogen. When it has abstracted this acidic hydrogen, now this sigma bond pair of electron will be shifted towards the nitrogen. Now when it has shifted towards the nitrogen, now the nitrogen will get the negative charge, right? Then after getting the negative charge on the nitrogen, we are having the Br. Clear? Now it will be attacked from the back end. Now the Br, it will take this bond pair of electron and it will be eliminated. Now here we will get the R, double bond O, and here it is the NH, and here it is the Br. Clear? Then again we are having the base. Again this base will readily abstract this acidic hydrogen. Again this bond pair of electron will be shifted towards the nitrogen. Right? After shifting towards the nitrogen, now the nitrogen, it is having the negative charge. Right? And here we are having the Br. Now here the Wolf rearrangement is used. Which one? Here the Wolf rearrangement is used. Right? In this Wolf rearrangement, what? This negative charge on the nitrogen will be delocalized, and this R minus, it will go and attack to this nitrogen. Br being the good leaving group, it will be eliminated. Then what it will form? Now we'll see. Here this carbon and the double bond O, and the nitrogen and the carbon, we are having the double bond, and the R, it has been attacked. Right? Again we are having the OH minus in the solution. OH minus, we are having the solution. that OH minus, it will go and attack to the which one? This carbonyl carbon, sorry, this carbon. Now this pi bond will be shifted towards the which one? Oxygen. Right? What will get? R, N, double bond, and here it is a carbon, and here it is a OH, and we are having the O minus. Now this is in the form of the enol. Now enol tautomerization will be happened, right? And this nitrogen, it will get the negative charge, and this proton will go and attack. What it will get? R. Here it is a NH, right? And there C, double bond O minus, right? Then after that, again this negative charge on this oxygen will be delocalized, and this bond pair of electron will be shifted towards the nitrogen. As the CO2, it will be eliminated, and what we'll get? We'll get the primary amine. We'll get the primary amine. Right? Now we can see whatever the carbonyl carbon we have taken. Now one carbon has been less in the product side. When the descent of the oxygen will be happened at the product side. Clear? I hope it is clear for you. I hope it is clear for everyone. Now these are the some preparation methods of the which one? Amines. Now the mainly what are the important preparation methods of the amines we have done. Now the tomorrow we'll see the chemical property and the electrophilic aromatic substitution reactions of the amines, then followed by the different reactions we are going to see. But now clear? Now the tomorrow we'll see the more number of questions regarding the preparations of the amines, and next one in the chemical properties of the amines also we are going to see. Right, now I am stopping the lecture here. If you are having any concerns, you can ask. My dear friends, anyone, if they are having any concerns, they can ask me. If you are having any concerns regarding the lecture or anything, if you are having any concerns, you can ask me. Now we'll do the tomorrow plenty of the reactions, questions, and chemical properties. Actually, the chapter is very small, but concepts are very high. Okay, fine. Okay, my dear friends. Now I was ending the lecture. Now see you tomorrow. See you tomorrow with the chemical properties and followed by aromatic electrophilic substitution reaction of the aniline. Okay. Okay, my dear friends, anyone is in the live? Still anyone is in the live? They can, if you are having any concerns, you can ask. Good night, Pranit, good night. Bye, Dinesh. Try to solve the n number of questions. Whatever the doubts you are having, just you mark it and try to ask me, okay? Try to solve the questions, n number of questions. More the n number of questions if you solve, more you will get. Okay? And try to maintain the short notes by your own. If you maintain the short notes by your own, it will, the more the reactions will be remembered for you. Already I was provided the each and every reactions and the conversions also I was provided. My dear friend, once you go through it, okay? Okay, but if you prepare it by your own, it will be more you can remember, because organic, they will not ask more complicated conversions also. Just they will make you twist. That's it. Molecule, they will twist. That's it. If you are in the stage to identify the given molecule, it is very easy. Okay. Okay, my dear friends. Okay. I was ending the live. Now see you tomorrow.